It's 6 a.m. Let's route between VLANs, shall we? All right. This is where we left off with a little twist. And if you have not watched the previous videos, what are you waiting for? I don't know what you're doing with your life. Go and check out the other videos on this series. So I have here. Let me see. I have here our switch console. I have here the new guy console. I have here PC1 and I have here PC3. So these are what we need for now. So as you remember, PC1 is on VLAN 2 on this subnet, PC3 is on this VLAN on this subnet. And now I want these two guys to communicate. So if it works for PC1 and PC3, it should work for the others. So the new thing here is router 1. And we're going to route between VLANs using a dedicated external router. On the next video, I will show how it's done using the switch himself if it's a layer 3 switch. So this is a layer 3 switch. This guy could route between VLANs himself. He would not need the router to do nothing, but we will use the external router because, well, it's fun and it can be useful sometime in the future for you guys. And also in the exam, it's going to be something nice to have and nice to know. All right. So let's get router 1 going for now. So first things first, let's connect the router 1, not this. So let's connect router 1, I don't know, 00 to where? Let's use the last one. This is an old school habit of mine, which is the first or the last port. It's connecting to the external router. That's just my own habit, my own custom. You do whatever you. It doesn't have any predefined thing to be done. So just connect to any interface. So cool. Let's get the router console going back. So this is PC3. And where is my router? There it is. And I forget which port I used. And it was port what? I forget. 00. Am I right? Yeah, I think it's 00. We can find out soon enough. So let's put this somewhere we can see it correctly. So if you're watching this in a short form, come and join me on long form. Ozzoy Beats on that video channel. I'll see you there. And for the long form peeps, let's go. Yeah, so let's do a quick show run here. Show run. And it was 00, wasn't it? I forget. Which port did I use? It was 00, right? Yeah, let's find out. So let's go to interface Ethernet 0/0. Let's do a no shutdown. Since this is a router, all interfaces are shut down by default. I forget which port I used. Jesus, so CDP neighbors. Yeah, it was 00, so it's there. Cool. So I connected 00 from the router to 3-3 of the switch. So let's get the switch console here. Switch. Let's go to interface. Interface Ethernet. What was it? 3/3. And basically the connection between the router and the switch is going to be a trunk port. Okay, a simple trunk port. So switch port, mode, switch port, trunk, encapsulation, port 1Q, switch port, mode, trunk. And we just do a manual trunk here. So right now it's going to stay, the trunk is going to stay, and basically that's what you need to do unless you want to apply a filter, which you can. So let's do show interfaces trunk. And so this it shows that trunking, which is a lie. It's not the trunk still on the router side, but we will make believe that it is true. Okay, that's fine. And also we kept the native VLAN as 1, which is fine. For now, it's fine. On both trunks, it's fine. Okay, so just to prove you guys that this is not working still. So let's go to, not this is switch 1. Let's go to PC1. So ping 10.333, which is PC3's IP address. So show IP. They don't connect because they don't have gateways, because they are in different subnets, which again I discussed this in a previous video. Go check it out. So in this case, it shows up as a trunk, but it's not a trunk yet. I have done nothing on the router side. And I forget, it was 00. Jesus, my memory just sucks. Okay. So let's go. It was 00 retro CDP neighbor. It was 00 on my side. It shows trunking on the switch side, but it's a complete lie. So let's go to 0/0. So this is how it works, okay? So on the router side, what I'm going to need to do is this interface, which is 0/0. I'm going to kind of logical divide it, and each in what things we call sub interfaces, and each sub interface is going to belong to a VLAN. So I'm going to create subinterface.1. You'll see it in a second. It's going to have its own IP address. This is going to be the IP address of the gateway of the corresponding VLAN. Okay. So if this belongs to VLAN 2, for example, it's going to have an IP address for VLAN 2. Again, this is going to be .2.3 for VLAN 3. It's going to have its own IP address for VLAN 3, and so on and so forth. So each subinterface is going to have an IP address, and that IP address is going to be the gateway for the PCs on that VLAN. You'll understand in a second. It's really easy to understand. So I'm going to retype this in .2. That's a subinterface.2. Encapsulation .1q2. This means it's going to be the interface that's going to belong to VLAN 2, and IP address. This is going to be the IP address of the gateway of the PCs on that VLAN. So 10.2.2.254. Again, it doesn't have to be 254. It's just a habit of mine to use the biggest number as a gateway. Now, same thing for .3, .1q3. This is going to be the gateway for the PCs on VLAN 3. And now I'm going to do the same thing for the native VLAN. .1q requires a native VLAN. I forgot to explain that in the previous video, but it's easy to explain. .1q requires a native VLAN, which is kind of the kind of a black hole of a VLAN. I'll explain that in more detail in a separate video, but for now, we'll use VLAN 1. It will suffice for now. It's very easily changeable to something else. Or we can just change to something else to be more in line with security features. So let's say it's going to be, I don't know, the native line is going to be VLAN 1000, for example. Encapsulation.1q 1000 native. And that's pretty much it. So typically, the native VLAN should be a kind of a uninteresting and completely useless VLAN. And I mean, it's fine on this side. So let's go to the switch. Interface Ethernet 03.3.3 and encapsulation switch port mode trunk. What is the command to define the native VLAN? I forget. Switch port native. How the hell do I specify? I've completely forgot how to set a native VLAN. Switch port trunk native 1000. Yeah, easy enough. VLAN 1000. So easy enough. So the native VLAN must match in trunks. So for example, here it's the native VLAN is VLAN 1001 still. It's on a default, which is fine for now. We can change it in a second. So if this is one trunk and this is another trunk, the native VLANs are trunk by trunk basis. It doesn't have to be the same native VLAN for the whole network. Usually we do that for the whole network just to be easier for us to manage, but it doesn't have to be the same native VLAN for the whole network. It has to be trunk by trunk basis. If you want to use the same for all, it's fine. You can change it later. It's really easy. Okay. So basically, let's test VLAN 2. So basically, this is an IP address that should be pingable from VLAN 2. And this is the switch. I want a PC. So this is going to be 2.2.2.2.54. There we go. So basically what you're seeing here is PC1, it's pinging the router's interface on VLAN 1. So let's try PC3 too, to make sure that PC3 also pings its side on the PC3. So ping 10.3.3.254. So each PC on his VLAN is going to pinging his own gateway. So in simple terms, PC1 on VLAN 2 it's pinging the VLAN 2 gateway interface. PC3 on VLAN 3 is pinging the router's VLAN 3 interface, which means now they can connect, they can talk to each other. But not now because I have not defined the gateway yet. So let's go here to PC1. Where the hell is it? It's here. Now here I need to define IP address 221/24. I forget, how do I define the IP address? IP. It's just okay. IP address IP10. What was the IP address of PC1 again? 10.221/24, and the gateway is going to be 10.22254. This part of the configuration really depends if it's Windows, if it's this, if it's Linux, but that's for a different video. If you want to learn how to configure the network in Linux boxes, I have plenty of videos on my channel. Go and check it out. So let's do the same here. Oh, let's save so I don't forget. Save. So IP 10.3.3.3/24, gateway is 10.3.3.254. There is no duplicate, but thanks for checking. Let's save. So let's do one final check. So let's ping our side of the gateway. The gateway on our side, which is working, which means I should be able to ping PC, for example, 10.221. There we go. Now both VLANs are talking to one another. So which means that PC1 knows that his gateway is his interface on the VLAN 2 side. PC3 also knows that his gateway is on VLAN 3's gateway side. So in order to communicate, you just need to, let's put the blue here. PC1 will just contact the gateway. Gateway will route to the other interface and connect there, and also the other way around. Okay. So basically, router 1 is now routing between VLAN 2 and VLAN 3. If in the future, let me get the routers. This is the switch. This is where's the router? There. So which means that if in the future you need to route, okay, now I'm routing between VLAN 2 and VLAN 3, okay, which is the ones we have. This does not have an IP address because it's just there to be the native, which is something we need to match in the trunk with the switch, which is fine. If in the future VLAN 4 pops and it's a 10.4.4, we just create a new interface here with 10.4.4.254, for example, and now it's our gateway for VLAN 4, and so on and so forth. We just need to make sure that you would just switch to. Okay, so in my case, I don't have a filter. Okay. So what was the port? Was the very last one. Okay, this one here. So let's just do something cosmetic, but it can be useful. Interface 0.0, 3.3, description, interface to router 1. Okay, this can be useful in the future. Now we just check the config again. There we go. And .1q native it's 1000 that matches the other side, and it's a trunk port. I don't have a filter here. I could have one, and I will add one. I mean, why not? Let's do things by the book. So conft interface ethernet na ka-chow na bam. Done. So everything is done by the book as it should be done. So this is trunking with the router. Native is 1000. The allowed VLANs are that, and this is trunk. So if you want to add VLAN 4 to the equation, on the router side we add one interface for VLAN 4, adjust the IPs, and increase the filter to include VLAN 3 and VLAN 4. and so on and so forth. Let's switch the native VLAN for in this situation here to 1002, so it's cleaner. So let's go to this guy here. Okay, Conf T, and we also do the 1000 here. Fine, and let's do description, connection to switch to. This is very important when the network grows. To have descriptions in the interfaces can really help. So let's go to switch 2. It's here. So let's find out. I forget what is a trunk port here. It's 0. It's that one there. So conf T. We go here. And see, native VLAN mismatch. Switch 1, it's on a native switch 1, it's VLAN 1000. Switch 2, it's still on VLAN 1. So we need to fix that, and we'll do it. Where is my switch 1? This is just me being lazy, copy pasting stuff, but this makes life much easier and faster. So description, connection to switch 1. Cannot type. We save. There we go. Show interface is trunk. It's trunking. Native VLAN now matches, so we don't see the message anymore. So this is looking better and better as we go, as we progress. All right. Which is now on switch 1. This connects to some access VLANs. This connects to other set of access VLANs. We have now a trunk to a switch, and we have a trunk to the router. So basically this reflects this. So this is a routing between VLANs. This is a trunk between the two switches. Our native VLAN now is 1000, and all VLANs are connected. I just need to add the gateways to the remaining PCs. I have to add the gateway here, add the gateway there, add the gateway there, and add the gateway there. But I will do this off video, so I don't bore you guys more than it's enough. So right now, what we did in this video, we added router 1, which is an external router routing between VLANs. This will work for the most case, but just be aware that this may become a bottleneck. Okay, this connection may become a bottleneck depending on the actual network load, because now I have that link being hammered with routing between VLANs. In this case, you don't have much traffic, so it's doing not much. But as traffic volume rises, that link may become a bottleneck and may get swarmed with traffic, but everything it goes through there between VLANs. That's why using a layer 3 switch can be a better solution for performance-wise. But that's for the next video. Watch and rewatch this video multiple times. Ask any questions you may have in the comments below. I love you guys. I love my big, beautiful bastards. Like, subscribe, hype, comment, do all the stuff to get this channel to blow up more and more and more and more. I want to help as many people as possible. Like, subscribe, hype, and comment. And I'll see you in the next one, guys.